Welcome to this inLab 15.0 tutorial. With its new design and functions, inLab 15.0 offers you the ideal support in all your design steps, from scanning to receiving digital impressions, through to designing, milling, and grinding restorations, models, or surgical guides. With the new software, it is now also possible to design partial frameworks for removable dentures. In this video, we will show you the workflow of the inLab 15.0 software using the example of a 6-unit bridge. In each work phase, we will become acquainted with the main new functions. When first opening the software, a so-called start screen will appear. It is divided into different areas: an area for the job, the case, and a preview area. In the first section, there is a search window in which one can scan for a dentist or patient in the database. Enter the name and then click on the magnifying glass. The dentist list can be arranged just by clicking on the triangle. It is possible to change the size of the frames. Alternatively, one can arrange the frames in other areas by clicking and holding the left mouse button down and dragging the frame into the desired position. Click on the pencil symbol when editing an order. It is possible to edit the patient's name or later enter or change the technician's name. The date could also be edited. To save the changes, click on Save or Cancel to ignore any changes. By clicking on the trash bin, the order is then deleted along with all other assigned cases. The jobs could possibly encompass many cases. These can be found under Case. Cases are ordered by name and date. When opening an orange highlighted case, click on Open Case. By clicking on the pencil symbol, the name for the case can be changed. Confirm the changes by clicking Save. By clicking on the X symbol, the changes will then not be saved. It is also possible to export cases or to delete. Only the case in the orange highlighted field will be deleted. In the third area, the preview of the case along with the design data is displayed. One also sees the software version along with the acquisition system being used. To open a new order, click on Add New Order. In the event that the case is being assigned to a new dentist, change the name of the dentist. If the case is for an existing dentist, select the dentist from the list in the Start screen. Only after filling in all the necessary frames will the next step become active and a new case can be added. Click on New Case. The administration phase opens with all its indications. In order to select a bridge, click on the frame Bridge Restoration. For the prepared teeth, choose Crown. In the design mode, choose Biogeneric Individual. Afterwards, select the prepared teeth. After this, the pontics are chosen. Select which machine is to be used for the case. If there are more than 2 milling machines available, click on Select Milling Device. In the option Generic Machine, it is possible to configure a third-party milling machine if you wish to export the restoration as a .stl file. In our case, we will use the MCX5. Follow up in the Step menu by choosing which type of material is to be used. The different materials are sorted by manufacturer. If only certain particular materials are ever to be used, the other materials could be faded out. Open the System menu. Click on Configuration and on Settings, then on Material. It is possible to completely fade out a manufacturer or chosen materials from a manufacturer, or just fade out certain block sizes or disc heights. When completed, click on OK and follow up by clicking on Exit Configuration. In this case, we will be using Sirona's In-Chorus TZI-C material. After choosing the material, click on OK. Back under Administration, we'll see the Case Details window. To toggle it off, click on the Minimize tab. To toggle it back on again, click on the frame Case Details. The side panel can freely be placed anywhere on the screen. When you click on the arrow, details of the restoration will appear. The size of the side panel can also be adjusted. By clicking on the double arrow, we move on to the scan phase. The InEOS X5 goes automatically into the load position when moving into the scan phase. On the bottom part of your screen, you'll find the three stand image catalogs: upper jaw, lower jaw, and the buccal bite. Additional catalogs can be added if needed on the side panel under the option Add Catalog. The scan window can be enlarged, which gives you the ability to better recognize different options. To acquire images with the InEOS X5, there are three methods available. Die scans are suitable for single copings or for multiple dies on bridge work. The automatic jaw scan for all cases, in particular for large, complex jobs and jobs that require the highest accuracy. And freehand scanning for small, simple jobs, with the option to add additional images from different angles. Under Import, you have the possibility to import an STL model in a catalog. In our case, we will first scan our dies under Rotation Scan. To do this, click on Rotation Scan. Being that there are a number of dies, we'll click on Multiple Dies and then Start. The scanning process begins. When the rotation scans are completed, replace the dies with the model and click on Scan Jaw. The complete model is automatically scanned. There are two scanning options. With Capture Area, gaps in the model while scanning are automatically recognized and closed. This is the recommended scan mode to use when rotation scans of dies are not possible. The reduced scan is primarily used for the opposing jaw, or in our case, on models with removable dies in which rotation scans have already taken place. Choose the option Capture Reduced. Afterwards, click on Start. During the scan, the rotation scans of the dies are being calculated into the model. When this calculation is completed, it is now possible to close small holes by double-clicking on them, if necessary. When your master model is completed, click Continue in order to proceed to the next scanning phase and image catalog. Choose the lower jaw. You will see that the previously scanned upper jaw is now being calculated. This shortens the waiting time of the model calculation considerably. Capture Reduced is already chosen. Afterwards, click on Start to begin the scanning process of the lower jaw. After completing the scanning of the lower jaw, we now take the buccal bite registration. We do this by clicking on Continue. Click on the Image Catalog Buccal Bite. Automatically, the option Capture Free is active. With this option, you have two choices: Capture Manual, in which you manually click the Start button, or Capture Auto, in which the scanner will release an image when the model is held perfectly still. The image will automatically be taken. Click on Capture Auto. By choosing the upper or lower jaw, you can determine by clicking on the Model Options icon how the model is to be calculated. Click on Model Options. Choose Reduced in order to acquire a model that just contains the tooth arch. This is usually sufficient when designing crowns or bridges. With the option Complete, you will obtain a model with all soft tissue information, such as upper jaw with palate information for design of removable partial dentures. When all scans are completed, click on the double arrow to move into the model phase. If it should be necessary to edit the model, one can do so under Edit Model. Here it is possible to cut off parts of the model or to replace, add, remove, or smooth areas. In our case, we will skip this part. Click on Buccal Bite Registration. In this step, the virtual models, upper and lower, are aligned through the Buccal Bite Registration. This step is automatically carried out by the software. If desired, the occlusal contacts can be visualized. To do this, first click on Analyzing Tools, then on Contacts. Clicking on Contacts again will close this option. In case adjustments are needed in the bite, it is possible to make alterations with the given tools. For example, with the option Move Jaw. In our case, we will do no changes and move on to the model axis settings. In this step, we will determine the axis of the model. This step is important in order to achieve a best possible first proposal. First, we adjust the model on the arch. It is irrelevant if the upper or lower jaw is first used, because both jaws move simultaneously and parallel to each other. Every tooth has to be more or less in its respective quadrant. Align the central incisors according to the illustrated center line. From frontal view, the center line and the occlusal plane are checked and corrected if necessary. Finally, the occlusal plane is adjusted in such a manner that the mesial incisal edge of the lower central incisors and the distal buccal cusp of the first lower molar lie parallel to the horizontal line. Typically, the incisal cusp of the lower canine protrudes above the occlusal plane. The next step is defining the jawline. First of all, the blue colored dots are positioned between the central incisors, one between the canine and first premolar, and the other between the last premolar and first molar. The last blue dots are placed behind the last molar on the middle of the jawline. Click and drag the dots to the appropriate positions. Subsequently, the tooth numbers are positioned over the prepared tooth. This is to allow an ideal implementation of the automatic trim and margin finder. The next step is trim. The model is automatically trimmed. If necessary, there is the possibility to reverse the trimming and to trim manually by clicking the Undo button. Using the Restoration selector in the object bar, all of the single trimmed dies can be checked. The preparation margin is then checked. The preparation margin is automatically proposed. If the preparation margin is not correctly given, it can be redrawn by clicking Undo. If corrections are needed, smaller areas of the margins can be manually corrected. Using the Restoration selector in the object bar, single dies can be selected in order to inspect the correct adaptation of the preparation margin. Optionally, the shoulder rest area of the die can be edited and toggled on and off. This is illustrated by a green line. Between the preparation margin and the green line, spacer is not applied. Above the green line, spacer is set according to the given parameter settings. After all preparation margins are correctly edited and/or checked, we continue on with the insertion axis. The insertion axis is automatically proposed. This can be edited in 3 different ways. One can move the orange ball in the target, or directly move the arrows on the teeth. The third way would be move the model on the screen for visual assumption and then click on Apply View Direction. After setting the axis for the bridge, one now has the possibility to check and edit the insertion axis for each individual die. Do so by clicking on the single die below in the object bar. Click on the double arrow in order to enter the design phase. New in inLab 15.0 software is the division of the spacer parameter in radial and occlusal. Each area can now be individually set. In addition, there are 2 parameters in which one can determine and edit the gradient of the preparation margin. This defines how flat or how steep the margin area of the crown should ascend. The second parameter determines how long the margin should ascend. By clicking on OK, the setting will be implemented. If the changes should be trashed, then click on Cancel. Morphology is the next step. In this step, the occlusal anatomy and the form of the tooth is determined. There is a distinction between anterior and posterior teeth. In cases with anteriors, there are 3 different options. The first is biogeneric. For the initial proposal, the full jaw is taken into consideration, not only the immediate neighboring tooth. With the second option, one can choose between 3 different basic tooth forms: ovoid, square, or triangle. The third option for the initial proposal would be derived from the tooth database. To open the database, click on Tooth Database. Then choose the manufacturer. Then choose the tooth form. In our case, we will choose biogeneric. In order to design the posteriors, click on Posterior. One has the choice between biogeneric or tooth database. In our case, we will again choose biogeneric. After the morphology has been determined, click on Positioning. In this step, one can scale, rotate, and move the restoration. When using a given tool on a unit, the tool stays active when moving to another unit on the restoration. To change to Scale, hit the space bar or click on the option Scale. To retract changes, click on Undo. If one wants to use a tool simultaneously on multiple units, it is possible to group the units. This is done by holding down the Control button on the keyboard and left-clicking on the units that should be grouped. Click on Escape to ungroup. You could also press Shift and click on the first and last crown with the left mouse button. The units between will automatically be grouped together. With Group function, the complete restoration can be moved. If the linear icon is not activated, the software moves the crowns in a restoration along a biogenerical path. If activated, the grouped crowns are all moved along an even linear path. By applying the harmonic positioning option, the initial position is ignored for the benefit of having a harmonious jawline. This way, the malposition of natural teeth can be corrected to a certain extent. This could usually be used for larger cases. If the option Unadapted Proposal is activated, the initial proposal will follow the guidelines of the biogeneric. This means that proximal and occlusal contacts will adjust according to the parameter settings, and minimal thickness will also be taken into account. If this option is not checked, the restoration will be calculated in a ratio of 1:1. When clicking on Edit Restoration, the initial proposal will be calculated and, if desired, can be modified by applying the available tools. Let's take a look at only the tools that have changed in inLab version 15.0. After an element on the restoration is active, one can only choose the tools that are applicable to the given element. For example, if a prepared crown on a bridge is active, then the tools to edit connectors or pontics will not be selectable. When changing to connectors, the suitable tools can be selected. Now click on a pontic. Here, one now has the possibility to edit the baseline. You therefore need to click on Edit Baseline. With the given tool Drag Line, it is possible to slide the line to another position. By using the right mouse button, one can lengthen or shorten the line. Drag the line to the desired position. The software will recalculate the changed position. Reverse changes by clicking Undo. It is also possible to totally redraw the baseline. Click on Edit Line or push the spacebar to change tools. Start editing by double-clicking. The lines can be fixed with a single click. Finalize by double-clicking. To turn off the tool, click on Edit Baseline. Let's take a look at the reduction tool on the anteriors and premolars. Click on Reduce. First of all, we'll group the 4 units. By shifting the slide bar, we determine the reduction strength. The software saves this setting for the next restorations. The reduction area can be customized, for example by entering a short collar around the lingual and proximal sides. Start by double-clicking. Determine with the blue line the desired area. The lines can be fixed with a single click. Finalize by double-clicking. Click on Apply to see a preview of the reduction. By closing the tool, the reduction will be conducted. The part that we designed as a collar stays in place. One can undo the reduction, for example to enlarge the reduction, by reopening the tool. Afterwards, click on Undo Reduction. Change the reduction by using the slide bar. Click on Apply. Then close the tool. By clicking the double arrow, we step into the production phase. If the designed restoration is to be milled or grinded in an MCXL, then this can be accessed directly by clicking the appropriate option. Since we are using the MCX5, we will need to export the restoration data into the CAM software. The option to export into the inLab CAM software has already been chosen. Click on the bottom, Export to inLab CAM. The restoration will be saved as a CAM file. This type of file can only be read by the CAM software. You will receive a message that the file was successfully exported. There is also the possibility to export the restoration data as a .stl file. If this is the desired option, then click on the option Export to Folder File. In the Step menu, click again on Export to Folder. Choose in Windows Explorer the location where the file is to be saved. Follow up by entering a name to the file. Now choose the type of file, in our case, .stl. Close the session by clicking on Save. Thank you for your attention. We wish you lots of success working with the inLab Software 15.0.